Welcome to Intabor Institute's Introduction to Project Risk Analysis. Part 4, Schedule Risk Analysis, the portfolio effect. Now the portfolio effect is something that's used in the financial industry where they have large interrelated networks. And it's used to model how changes in these relationships can affect the overall forecast that we see. And it's actually something that's pertinent to our schedule risk analysis. It actually we can actually show how this portfolio effect in combination with right-skewed distributions will actually cause our project, the most likely outcome of our project, to slip to the right. It will actually increase the expected duration of the project. Now we can see this in this example that we have. We have 10 activities that all have finished start activities. So we have a precedent network of 10 activities. And we can see that the base duration, the expected duration, is 50 days. Now we've applied some uncertainty to that, and we've given it a right skew, which again is characteristic of schedule activities. We're going to run a calculation. Now, what we'll see in the analysis, we'll look at the project summary, is that our original estimate was 50 days. And it shows here that we have about a 2% chance that we'll meet that original estimate. And this is very typical for what we see, especially when we get in a first forecast, the original forecast, that they put the schedule together, and then they haven't yet run a simulation to find out, what the chances is that they'll make it. They haven't made adjustments. And one of the things we can see is this fairly steep S-curve. Now, the reason that this happens is that on right-skewed distributions that we have on the activities is that the most likely value is to the left of the mean. And that means the mean is higher. The average duration on these right-skewed distributions is higher than the most likely. So the peak of it is to the to the left of the mean. So, and what happens, and we'll take a look at this in one of the activities on the Gantt chart. Let's do a quick look at this. What we can see here is, if you remember, when we look back at that chart, it was fairly steep. And what we see is a much more flatter line. And what happens when we have these right-skewed distributions on a precedent network? The most likely, which is over here, starts to tighten around the mean. It actually moves to the right. And what we end up getting, we go back to the overall project summary, is we have a much steeper S-curve. What's happened is this is shifted over to the right and it's tightening around the mean. And so we get a steeper curve. And this means that the chance when we have these long precedent networks with right-skewed distributions, the portfolio effect can have a profound effect on the ability for us to finish on time and on budget. So if we don't account for this, and the only way we can account for it currently is using Monte Carlo simulations. If we don't account for this, the chance that we're going to meet our original estimates is going to be quite low. And if we take into account our previous video, part 3, where we showed the effect of parallel activities and the merge bias, if you have a large complex project, you will have a large precedent network in combination with many parallel activities. The combination of the two can often show you that there'll be about a 20% increase in the expected duration of your projects. And if you don't run the Monte Carlo simulations on it, you will never see or be able to understand what's causing it and how you can address it.